Okay, hopefully on this assignment you were able to get through like maybe 7 and 9 by yourself. If not, you can let me know. But I thought I would just do some of these here, just kind of try to fit as many on one video as I could that were assigned. If you look at this, there's a GCF here. There's 3 terms and there's a GCF. It's y squared. And if I pull it out, y to the 4th, take out y squared, there'd be y squared left over. This minus 2y cubed, there'd be a minus 2 left over. And then minus y cubed over y squared would be a minus y. Now you might think you can't do anything with this, but if you look, they just have some of the terms are out of order because they didn't put it biggest exponent down to smallest exponent. What I really have here is y squared minus y minus 2. And I could factor this. I could say I could multiply to get this negative. I'm looking inside the parentheses. I'm just going to keep up with the y squared, by the way, okay? And then I'm going to factor what's in parentheses. What can I multiply to get negative 2 that adds to be negative 1? I'm looking at this is the number on the end, this is the negative 1 in the middle. Well, if you think about it, 1 times negative 2 would be negative 2, and 1 plus negative 2 would be negative 1. So I could write down y minus 1, y minus 2, and then that one's factored. Always remember to go back and rewatch it or pause it at certain points if you just need to hear pieces of this, because I know I'm going fast. All right, so let's just kind of keep going and look at it. Sum 13 is another one that's a factoring by grouping like in section 5.10, and the reason I know it is there's 4 terms, right? So that's how I knew what to do here. So I'm going to look at these 2 terms together and these 2 terms together. All right, so looking at the first 2 terms for the factoring by grouping, you think first of all, you look for a GCF in just the first 2 terms, and it is x. So I can pull it out. And my leftovers, x squared divided out x would be x. I could copy down the subtraction sign, and if I have x, y, and divide the x out, I'll have a y left. Now remember that we said when we've got factoring by grouping, and we see that this little, in between the sets of 2 terms, there's a subtraction sign. We want to factor that out. So I'm going to divide a negative 1 out of both terms. That usually makes things clear up like you need them. If I have a negative x and I divide it by negative 1, a negative by negative divided by negative is a positive. If a plus y divided by negative 1, a positive divided by a negative is a negative y. Now, do you see how when I did that, my terms turned out to be matching? They would not have turned out to be matching if I hadn't factored out that negative 1, but maybe I would have realized it and gone ahead and done it. All right, so my new GCF is this x minus 1 that I see in both terms. I'll write it in red since I underlined it in red. And then my leftovers would be this x right here, and then this minus 1, and that one's factored. Okay, I'm just going to keep going and doing them in order, and when I run out of video, that's all I'm going to worry about doing for video. 17 is a cubed minus 2a squared b plus 3a squared minus 6ab. And again, I notice there's 4 terms, so I'm thinking, okay, this is a factor by grouping problem because there's 4 terms. And that's, anytime you see 4 terms, unless you can combine some, that's what you need to think. And none of these are like terms. It's not like I could put any of them together anyway. Excuse me. So we'll look at these. I'm going to group them those 2 together and those 2 together. You just always take them as they come and don't worry about the order so much. Out of the first 2 terms, both of those can have an a squared divided out. So I'm going to take it out, and that's my GCF of my first 2 terms. And I would have an a, if I take a cubed and divide a squared out, I'd have an a left over. I'd have the 2 left over. The a squareds would go away, and I would have a b here. Here's my leftovers of the first 2 terms. I'll just put left for leftovers. Now for the second set of terms, I look at those, and there's a plus sign, so I'm not going to mess with any negatives or anything. I'm going to factor out a 3 and an a. I notice there's a 3 and an a is the GCF on all those terms. So I'm going to say, well, what's left now? 3a squared, divide out the 3a is a. I'm going to copy down my subtraction sign and say 6 divided by 3 is 2. Or I could have thought negative 6 divided by 3 is negative 2. We could have thought differently. We took the a out, and there's the b left. Do those 2 parentheses terms match? Yes, they do. Hallelujah, because that means I'm almost done. So what I'm going to do is say, okay, does a minus 2b, that's my new GCF because I've got 2 big long terms. And then my leftovers would be, I'll write them in a different color, they're the things that are out front, a squared plus 3a. Now, I did not check for something at the very beginning, because a lot of time when you see a factor by grouping problem, you don't usually mess with taking a GCF out of all terms, but we could have. I need to notice something. I always kind of need to look at my answer and say, could I have done anything else to factor it more? And I could. Look right here. Isn't there a GCF there? It was up there in the original problem. I just didn't check for it. I forgot, and that happens a lot. And so I want to. It's almost kind of good that it happened, because I can show you that if it does happen, all you do is when you get down to the end, a squared plus 3a, can't I pull an a out of both of those? A squared take out an a would be an a left. 3a take out the a would be a plus 3 left. I wouldn't write it that way. Anytime you have a single term like this a, you're going to write it out front, and then you have a minus 2b and a plus 3. So we're just going to write it in a nice, proper way, and we could actually factor it, and if you look back up at the top, you see that there was an a in every term that I could have pulled out. I just missed it. So if you miss something, take it out when you notice it at the end, but that means you always need to be checking at the end to make sure you didn't miss it, okay? Okay, 17. That's 43. I think we did 43 in class, so this will be good. A to the fourth minus b to the fourth. 43 took us forever, so I'm kind of glad it's not going on the video, because I doubt I could get finished with it before we ran out of space. I could think of this as, first of all, notice there's two terms. There's no GCF, is there? There's a subtraction sign in between the two terms, so I know this is probably a difference of two squares. Can I write it that way? Sure I can, because couldn't I square a squared to get a to the fourth? 2 times 2 is fourth. We have to remember our exponent rules. And then to get b to the fourth, if I think 4 divide out the 2 here, it would be b squared. So I can factor that as a difference of two squares. I can say, okay, whatever's here in the first spot, I'll put here and here, and it's an a squared. And whatever's here in the second spot, I'll put here a b squared and a b squared, and I need one plus and one minus. Now, I look, because I always want to check, can I keep going? And I can here. The first term won't, because it's two squares, but it's got a plus in the middle of it, and we cannot factor the sum or the adding of two squares, okay? But if you look right here, this is almost like the difference of two squares formula, isn't it? I could think, what do I square to get a squared? I square a, so I put it here and here. What do I square to get b squared? I square b, so I put it here and here, and I need one plus and I need one minus. And if you look at that now, there's nothing else that will factor. I knew these right here won't factor because there's no squares on them, so there's no really way to keep breaking them down if there's not a GCF. This one won't factor even though it is two squares because of the plus sign, so I know I'm finished. I'm going to go backwards now. Since I skipped some at the very beginning, I kind of thought, well, I don't have time for them, but I can fit them on the video, so I'm going to do them really quickly. This is kind of one of the reasons I thought these might be good ones for you to try. They're not as hard maybe as you might think. 5a squared plus 10ab plus 5b squared. First of all, is there a GCF? Oh, yes, there's a 5 and everything, so let's divide it out. That would be an a squared. 10 divided by 5 would be a 2ab, and then 5 divided by 5 would be a 1b squared, and I'm just going to write down b squared. Do you see why it's so nice to take your GCF out first? Because if you look at what's left in there, I could come off to the side and I could say I'm trying to find things that multiply to give me, just looking inside the parentheses now, to give me the number on the end. There's not a number out in front of my a squared term, so this is an easy one. I'm trying to multiply to give me 1, and at the same time, the two numbers that multiply to give me 1 have to add to give me 2. So, again, you don't have to use this organizer. I'm just using it as an explanation tool. What would work? Well, 1 times 1 is 1, and 1 plus 1 is 2. So I think, okay, I need a 1 and a 1. The a squared, I'd put the a and the a here. It's a positive 1 and a positive 1. But now I got to tweak this a little bit because of this b squared term here on the end, and I see there's a b in the middle. If I put a b in here, that would actually work out. Let's check our middle term. That's 1ab and 1ab. That makes 2ab. But mathematicians don't normally write down that 1 because it's not really necessary. 1b is the same thing as b, so they would write it down like this. I'm going to try to fit at least the start for number 9 in just because we can. 4m cubed minus m. First of all, I check for a GCF. Oh, they both have an m in them, so that becomes 4m squared. And then m divided by m is 1. Don't just leave something off. That won't be right. Now, I'm going to carry along the m, and if you look inside the parentheses, there's two terms, and there's a subtraction sign. And so I'm kind of thinking maybe this is a difference of two squares, because when I have two terms, I should always check for that. And if I look, it really is. I could square 2 to get the 4 and m to get the m squared. And for 1, you can always square 1 to get 1. So if I want to factor this, I'm going to, okay, it does factor. And if you remember, this 2m here, since it's in the first spot, it goes in the two first spots here and here. That's how you're going to get your 4m squared back. This 1 right here goes, since it's in the second spot, it goes in the second spot. And I need 1 plus and I need 1 minus. And I check, is there any GCFs I forgot to pull out? No. Are there any squares left? No. So I know I'm done.